Hi, welcome to this session of the J Champions Conference for 2022. My name is Josh Juno, and I'll be moderating this next session entitled 5 Tips on Creating Modern Cloud-Native Applications by the speaker, Rustam Mehmandarov. And please feel free to use the chat feature to ask questions. Rustam will go ahead and answer questions as the conference session is going. And with that, I'm just going to go ahead and hand it over to Rustam. Take it away.
Thank you very much, and thank you for inviting me, and also thank you all for joining in. Good morning, good afternoon, good evening to any of you and all of you all around the world. It's the funny thing how time zones work, right? I mean, it's middle of the day somewhere. Here it's kind of getting a bit late in the evening. It's 7 p.m. here in Norway. So, it's fun. So I want to do this talk not as a kind of broadcast where I talk for, I don't know, 50 minutes, 40 minutes, 60 minutes, whatever that will be. But I want to do it a bit more interactive. So I would kind of encourage you to use the chat, the one that you've been writing and saying hi and hi, everyone. And it's like I see some familiar faces, familiar names at least, so hi to you all. That's really great. To see you all here, and use the same window to write comments. I'll try to keep an eye. I'll do my best to keep an eye on them, and I have also Josh in the background that will help me if I miss something. He'll show the questions and stuff on the screen as well. So this is a bit of how we want to do it. Let's try to do it a bit more interactive. So back to this talk. So I created this talk some time ago as a kind of trying to sum up the things that people might want to know when they create this modern application, because there's a lot of talking about app modernization. There's a lot of talk about cloud. There is a lot of talk about cloud native applications, and all of that kind of might seem a bit magical to some extent, and a bit kind of what is this? What is this? What kind of sorcery is this? And what do I need to do to actually call my app as well cloud native and things like that? So this is kind of a very gentle introduction, or like things that you need to think about or might want to think about when creating those applications. A tiny little shameless plug is that we have another session with another Java champion, me and Anna Maria from on Monday, that will be doing also another talk where we do focus much more on misunderstandings of cloud native and what it actually, something misunderstanding cloud native, we called it. So, there will be another kind of continuation or build up on top of this talk as well in a few days. Yeah, I see a lot of really nice comments and hellos from all over the world. We see Germany and Chicago and a lot of different Missouri. Yeah, so that's really cool. It's really cool to see. Oh yeah, France, Mexico. That's really cool. So keep comments going, ask questions, write things, write your comments and things, and then we'll try to bring them and pull them into this talk. So the most natural thing, I mean, there is always, when you talk about like cloud and everything, it's probably a good idea to start with a tiny little disclaimer. And disclaimer, I mean, it's not really a disclaimer, but I just put it as a disclaimer because you see a lot of talks, enterprise talks starting with a disclaimer and long text of some kind of stuff in it. My disclaimer is a bit different. So basically what I'm saying is, I mean, there is no cloud. It's just somebody else's computer. You probably have seen stickers and pictures and stuff like that with the same text everywhere. And this is kind of what I want to convey to everyone, that just when I start talking about cloud and cloud native and all this kind of terms, I mean, it's not a magic, super fantastic, super magical thing. It is. I mean, cloud is somebody else's computer. It is still a server somewhere. But the thing is that usually cloud comes with some cool features that make our lives to some extent easier. And some of those things that I'm going to mention does not have to be on the cloud. It can actually be on your own local on-prem kind of services, but still utilizing those positive things coming from cloud native applications or way of thinking of that. When we talk about cloud native, so I will do right now something that I'm not supposed to do at all, and you should never do ever on a presentation. I'll show you a wall of text, and that is basically the definition of cloud native, of what actually cloud native is by CNCF. So Cloud Native Computing Foundation, that is kind of the unit or the organization that actually kind of maintains the whole things to do with cloud native and all those technologies around it and stuff like that. So they have this big wall of text, which is really nice to read when you're reading it, but it's something that probably you're not supposed to show on slides, because while I'm talking, you're probably way into reading it and you're trying to process and parse all those sentences and stuff. And I really don't want you to do that. I'll kind of try to help you with that. So I'll highlight the main words that I really want to focus on. And to distract you from continuing reading that wall of text, I will go even further. I'll remove all the other words. So now we're sitting with kind of the main gist of what cloud native actually is. And so we're talking about things like scalable applications, so applications that can scale, applications that can run or on public, private, or hybrid clouds. We'll talk a bit about what those different things are in a second, so I'll explain all that. We're talking about things like containers. We're talking about service meshes of different kinds, and microservices, immutable infrastructure, declarative APIs, and loosely coupled and resilient and manageable and observable and robust automation, or robustly automated, if you can say that. I'm pretty sure that's not a word, but anyway. And well, that are able to change frequently, and they are predictable, and they are like bringing very, very little toil to the whole game of deployment and development of those applications. So all that is like, this is kind of the main words that we want to bring with us further into. Yeah, that's really cool. I see that there is already a comment. What does cloud native means to you? Is it Docker and Kubernetes? Is it AWS Lambdas? Or what do you use when you implement production code? Yeah, exactly. So that's we'll get there. So hold on to that question and ask it again if I don't answer it very, very soon. So let's have a deal about that. So I'll get there to some extent. I'll try to keep. I'll try to show some examples as well, to talk about some examples as well. But so now we have a bunch of words, right? So the way my brain works, I mean, I always try to analyze and kind of separate and split things. So that's what I did with this kind of definition as well. So what I did here, I tried to see what this cloud of words, actually wordplay, but yeah, what does this, those words that we have here, what do they mean, and how you actually can put them in different shelves or different buckets or whatever you use to sort things out. So I ended up with this, right? So I kind of ended up seeing okay, look, here we're actually talking about what we're trying to build, right? We're trying to build scalable applications. We're, public, private, hybrid clouds, blah, blah, blah. And we also are trying to talk about, or we are talking about, how we do it. So we're using containers, microservices, immutable infrastructure, blah, 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 blah. And then we talk about a little bit about why. So, well, because we want to do all that, because we want it to be loosely coupled, to be resilient, manageable, and so on, so on, so on, right? And one of the ways of, like, if you want to, what should I say, persuade someone or to explain something to someone, or, where you want to explain some kind of new context, or basically sell in quotes some kind of concept to someone, you want to start with this. Very often we as developers, we might start from the wrong end. We talk about what they're going to achieve and what they will get, and then we'll talk a little bit about how we're going to do that, and then maybe we're going to mention a little bit about why and stuff. But usually the better way of doing that is actually starting the other way around, right? First, you want to address the problem. I mean, why do you want to do that? What will it bring? So if somebody is trying to sell you a car, they will say, imagine you don't have to do service on your car that often, or imagine how beautiful it will be on a sunny weather driving along the coast or something. So first they actually try to sell you why it might be a good idea, and then they will tell you about the why and how and what kind of car you will actually get. So I want to use a little bit of the same approach here as well. So I want to start a little bit about this why part, and then we talk about a bit more about how, and then we'll talk about the other things as well. So this is the plan. So the why. So the why is basically, you can also call the why also a set of needs. So usually when a customer comes to me or to my company, and by the way, just to give you a context, I live and work here in Oslo, Norway, and I work for a consultancy company where I've been working with more or less Java, cloud and architecture, and I've been working as a consultant for, I don't know what is now, 15, 16 years. And obviously I'm a Java champion since I'm part of this J Champions conference. I'm also a Google developer expert for cloud. So, I mean, there's a lot of things that I kind of see every day related in one way or another to architecture, to Java, to cloud, and things like that. So this 5 things that I put here is a kind of subset or frequent list of things that customers come to me in one way or another and ask about, right? So one of the first things, like the why thing, why do we want to do it, as opposed to doing things with the old way of monoliths and all this big chunks of software where you used to deploy it like once a year or 3 times a year or something, and building huge things. We want to increase speed. So time to market is an important thing, right? That's another fun thing. Oh, yes. There is a comment about lock-in. I will get to lock-in very soon. So, and it doesn't really matter which really cloud you put it on. I mean, if it not really depends on if you put it on cloud or not. It depends on really on what kind of technologies and what kind of things build in what kind of technologies you're basing your solution on. I mean, you can deploy it to AWS or whatever, Google Cloud, Azure, whatever, and still be portable and don't have much lock-in. And you can also deploy it on-prem and be locked into something that you picked. And we'll talk about lock-in in a second. But yeah, it's actually a very, very good, interesting point. So thanks for that. But first, time to market, because time to market is important. And we see that even more and more these days. I mean, I'm pretty sure all of you, at least most of you, can name at least 1 or 2 companies that succeeded or failed just because they released their product, their way of doing things just a little bit earlier than the competitor, right? Or they just deploy a new feature or a totally new product or whatever, So speed, time to market kind of thing is important, right? And if you deploy things in a big chunks of monoliths, well, it will take you some more time to actually restructure, rebuild all that monolith to the way you want. If you want to release a new service, a new way of doing things, new business process, whatever that might be, right? So speed to market, time to market. The other thing is agility. And agility is very related to time to market, but it's a bit more fine-grained. It is a little bit more about responding to change. So, say you have something out there, and you want to tweak it a little bit, or you want to replace one thing with another thing, another backend service with a new one, or things like that. So agility to change, how fast your application is able to kind of stop, switch direction, and just go full speed in that direction. So that's another thing that people very often ask about. Third one is reliability. And reliability is a kind of, it has a lot of different ways of thinking about it, different aspects of it. Reliability can be that your application is reliable in a way that it's going to be there when somebody needs it. So, when somebody goes to your, I don't know, URL, or opens some kind of app or something, there is a backend there that is able to respond, and it's there and it's snappy. Reliability can be something that, it will be able to scale depending on the number of users. So you have a service that is not very popular, so not crazy popular one day, and the other day, somebody writes about it, somebody posts a tweet about it, something, it goes totally viral overnight, and your application should still be able to handle it, right? If you deploy it in a bit more old way of doing that, again, like with monoliths, with on-prem servers and everything, will you be able to scale overnight? Will you be able to actually, say, oh, well, we went from 1 user to 1 million users, and it just works, without like buying all that hardware and software to begin with, and just making it available right away. So, a 1 million user worth application just standing there idling, and just waiting to be used, and right now it's just being used by one user. You don't get very good feeling by that, right? And I don't know if it's a good comparison or not, but think of like those super monster cars that are built for like high speed and high performance. Have you seen them idling? I mean, they're just basically, you can hear them barely surviving the idle mode. They just really want to kind of run and do things, right? This is how it feels like creating an application that is already scaled for 1 million users, and you have one, right? So scalability, availability, is it available for all kind of regions, all kind of groups, all kind of it can be geographical availability, it can be some other ways of like segmenting availability, right? Yeah, there's a comment about, okay, I'll get to that comment about lock-in and stuff in a second when I get to the lock-in, but yeah, I'll comment on that. Fourth one before we go to lock-in is resilience. Resilience is kind of related again to reliability, because if your application is resilient, it will be reliable. But what actually resilience means, and that's again can be different things. It can be different aspects of those things, right? It can be fault tolerance. So what happens if parts of your application fail? If something happens on one of your services and it just starts failing, what do? Do you actually gracefully show some kind of message and saying, something is wrong, we'll be back, or you kind of do exponential rollbacks in a way that you kind of retry, so you don't have to retry all the time and kill all your other services, but you can actually do it slightly. more graceful? What do you do if, say, services that are outside your control fails, and you want to be able to address all those issues? And obviously, under resilience, or it can be also under reliability, I guess, as well, is this thing of security, because you want your applications to be secure, and by security, it can be, again, different things. It can be DDoS attacks. It can be all this kind of authentication things, and can be different things. But still, you want to keep that in mind, and you want to be your applications to be able to handle all the aspects of security that is important for exactly your application. And another thing also under resilience goes is the observability. Observability is being able to see how your application is doing on such a level, so you can actually do something about it proactively. So, I mean, if you see that your application is going too crazy with some kind of on some kind of metrics, it can be CPU, memory, calls per second, something, you can actually automatically set up things to scale up or scale down, or do something about things before it goes really bad. And then now we are getting into this lock-in thing, and that's another kind of usually requirement in one way or another you hear from your customers. So basically, all those 5 things, things that you hear in one way or another, and feel free to add if you hear some other kind of requirements then that come over and over and over again. And this lock-in thing is getting kind of misunderstood very often. And well, spoiler alert, we actually took the lock-in thing into the other talk that we're going to be having about misunderstandings, because it is it is a thing that you have to be careful about. It's like you're mentioning here in your comments. I'm not saying you shouldn't commit to AWS services. If they fit your needs, it's fine. I only wonder if it's been taken as a why for the cloud, since you typically bound to the provider. Yeah, exactly. But then the thing is, lock-in is being quite often misunderstood, because people think that if I choose a specific cloud provider, I'll be locked in. You don't necessarily, right? If it is open standards, if it is standards that are similar, like, say, I don't know, let's say you are picking, you have a choice of using, you need a database, right? You go for, you can choose of something kind of openly accessible, or you can choose a super unicorn solution provided by that specific cloud provider. And you don't really care, but then it's always cool to go with the coolest and newest technology. So if you choose that super unicorn technology that nobody else offers, but it is like super fantastic, and it does not have to be that solution, you might have some kind of problems with login. But if you go with a managed version of, again, just for an example, managed version of Postgres, or MySQL, or something that is kind of widely used and accepted everywhere, and it's still managed service, so it's still not a VM with your own installation and from scratch installation of that Postgres or MySQL or whatever, that might be actually fine, because it's managed. You don't have to think about it and everything. And if at some point you have to move, you have to migrate, you'll be actually okay with doing that, because, well, it's more or less, it's pretty much standardized Postgres installation. So you can actually export things, you can dump into something, you can mirror to something, and you can switch to something else much, much easier. But then the thing is, whenever you do any decision ever, there is always a chance for lock-in. And then you need to do, what you need to do is to kind of think of trade-offs here. So you need to think of what will it cost me to migrate, and versus how likely it is that I will be having this problem and that I will be needing to actually migrate. And if the answer is quite likely, or well, there is still quite a big chance for that, or 50-50 or something, then you need to think, okay, how much will it actually cost me to migrate, to rewrite parts of it, to make it available somewhere else, right? So again, usually that part, I mean, I can probably talk for quite some time about lock-in and still not be done with it, because one thing, we always do that, like I said, and the other thing is that it's being misunderstood sometimes. Sometimes you just get people telling you, what, we just want everything to put on virtual machines, everything installed from scratch, and just put it on cloud. And then you ask why, and there's like, well, there is a chance that maybe someday we'll possibly migrate, and then we just want to take our VMs and put them in a bag and just bring them to somewhere else and just deploy them there. And then you're like, yeah, but I mean, it will be more expensive for you to run those things on whenever you while you're still running those. It will still be possibly not just drag and drop into another provider after all, because small changes and stuff, and all those things. And do you really want to spend all that money and resources and still have a little bit worse than using managed service, but it's still open source and everything, right? Yeah, so there is another comment on, there is a lot of comments about one specific provider. I don't really want to kind of make it about one specific provider, but in general, yes, it's like, I never understood how the companies that do multi-cloud can utilize the special databases available for a single vendor. Yeah, I mean, that's the thing, right? It's the thing is, like, if it works for your solution, and if it works for your application, and it won't cost you much to port, why not do it? But if you know that you'll grow kind of into that and you will have troubles moving, yeah, well, maybe you need to rethink your strategy, right? The thing is, the short answer to all of those challenges would be, it depends, right? And I know that's the answer nobody really wants to hear, but very often you'll end up with this kind of things, right? Mostly by abstracting away database instance lifecycle management outside the application. At the end of the day, your Java app just needs JGB. Yes, that's one way of thinking, right? But then you also have these things that different databases bring to the table, right? So some of them will be relational, some of them will be document. That's one thing. The other thing is that even though they're relational, they will have different kind of availability, response time, and everything. So some of them are more the kind of old school normal form, kind of 3NF, kind of that more into that. And then some of them would be, well, it's still relational database, but here we optimize to do like white table things, and then we can just dump things where you want, and will still be available all over the globe in millisecond, multi-millisecond, blah, 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 and it will still run. So it might, some applications, I mean, chances that you're writing one of those applications and you're not working for a like super big company are probably not that big. But if you have that kind of needs, you might need to go for a specific application, a specific provided service, right? Yeah, exactly. They all have unique capabilities. Yep. So perfect. Hello from Tatarstan. Yes, hello to you too as well. That's really cool. It's really all over the world, the crowd. That's really nice. I like that. All right. So now we talked quite a bit about why, right? Let's talk a little bit about what. So the funny thing, I drew all the drawings myself because I kind of started looking for icons. I couldn't find them, so I ended up drawing all those myself. And this, I kind of realized now that the scalable application icon reminds us of a tiny little virus we've seen drawings of quite a bit. I just need to say that this has been drawn before the latest virus pandemics actually became a thing, before the drawing of it was actually the kind of very popular. So there is no intended similarities between scalable applications and those little circles. It's meant to be like as a connection points and a way to scale than anything else. But I realize now that might be a little bit kind of confusing right now with a different point on viruses and how they look, and so at least certain ones. But anyway, that's it. Now we digress. So let's talk about scalable applications. So scalable applications are what are those? I mean, what is it? What is it compared to all the other things? And what are those cloud things that we've been talking about? So we talked about public or private clouds, right? And we talked quite a bit already about like different examples of that, right? It's been mentioned in the comments and everything. So it's Azure, GCP, so Google Cloud Platform, or AWS, or any other kind of. There's a bunch of others. There's Heroku. There's big ones, small ones. There is like all they come in all shapes and sizes, and all of them typically are called public cloud providers, or quite a lot of them. And there is also private offerings, right? When you create a cloud, but it's only accessible to a certain amount of a group of people, group of services, that would be kind of more private clouds. But again, that's the thing that we very often think about when we talk about cloud, right? Then people talk about two different things that are getting mixed up. So one of them is a hybrid cloud, and the other one is multi-cloud. So multi-cloud is basically when you mix and match between public clouds and different public cloud providers or private cloud providers. The reasons for that might be different, might be many. So some reasons might be that you need a super high availability. So if you cannot even dream in your worst nightmare that your one of the clusters or one of the kind of regions for the cloud goes down, and it will be a total disaster for your business, you might want to kind of do it on different cloud providers. So you do go multi-cloud. Another reason for going multi-cloud can be that offering in one cloud is better or cheaper or more available or whatever, and for offering for some other things that you're using are better, cheaper, or more available or whatever on another cloud provider. So you can actually kind of split things between those, right? And then there is a hybrid cloud. So hybrid cloud is a little bit different kind of animal. It is so this is a mix of a cloud, whichever kind of cloud it is, public, private, whatever, and your on-prem services, right? So this drawing on the right side is supposed to be a racks of servers. That's that's my drawings you can complain about, but this is meant to be a rack of services that you a rack of servers that you have on-prem somewhere in your own server room, somewhere in your basement or whatever, and then you combine it with usage of cloud. Reasons for doing that can be, again, many. It can be things like for example, the business you're doing, or the legal issues with sharing data. So you cannot put all the data that you have into the cloud. That might be one reason, right? Because regulations, company policies, whatever that might be. But that's the one of ways to one of the reasons to do that. Another reason would be that you are using some kind of super special unicorn hardware. I call them all unicorn, but you know what I mean, right? Like super special GPUs, super special something that is either not available, not as available, or too expensive to use on cloud. So you want to do those things on your machines, and then you do the other things on the cloud. But still, at some point, for some reason, you might want to combine those two. And very often, it's about data regulation and data privacy. Very often, many countries, I see this kind of issues, that you're not allowed to put some kind of certain kind of data onto a public cloud. or you need to know where geographically it will be stored, with GDPR and all the other things, or some other reasons as well. So that's the what we're trying to build. So we're building scalable applications that are able to scale. Obviously, that's kind of part of the name, and they can run all those three types of cloud. But that is an important thing to mention here. It does not have to run on the cloud. So, I mean, they're capable of running that, but you might as well just totally fine to run it on-prem, because cloud native does not mean that it has to be cloud. If you're not ready to go cloud, if you don't want to go in the cloud, fine, don't do it. Run it on your on-prem, but take some of those pointers, some of those ideas of creating cloud native applications. It will still make your life easier as a developer, and it will make your deployment and everything easier as a developer. So now we're getting, after all that talking, we're getting into the how. And this is the 5 things that I've been promising you all the time since the beginning, 5 tips. That's the 5 tips. And now hopefully they make a little bit more sense when we talked about why do we want to do that? What kind of needs do we have? And what kind of things we will have at hand when we create those things, those cloud native applications. And so here are the 5 things. And there might be more. And this is my take on it. And again, another very important point here is that you don't have to implement all 5 of them to say, what, I have cloud native, or you don't have to implement all of them in 100% degree, right? You can actually do that as much as you want, in as much as or as little as you want. But still, the point is, if you do it a tiny little bit of each, at least, it will make your life tiny little bit easier. That's kind of my selling point to you. But, take it with a pinch of salt or grain of salt or whatever, a little bit of salt, and your mileage may vary, and it depends, and all those kind of disclaimers, they're still valid here as well. So first one, loose coupling. So what do we mean by loose coupling? So, well, with loose coupling, we mean that things are in tiny little boxes, so you can actually connect and mix and match them the way you want. You want to, instead of going full monolith, because it will be easier to replace tiny bits of it, it will be easier to update parts of it, it will be easier to refactor and rewrite and add new features and everything, just by, instead of taking down the whole thing as what we used to do. I mean, when I started working when was that? I started my full-time job in 2006-ish or something. And we used to do that. We used to have servers. We used to deploy our applications. And we used to, everything was in one jar. And if you had to deploy a new version, you would have to kind of rewrite that and, and deploy a new version and take down the old one and so on, so on, so on. If you have loose coupling, you don't have to do that. You don't have that much downtime. You can have downtime on parts of your application instead of having the whole application taken down and stuff like that. So, which is nice. The downside it brings is that you need to now think about instead of thinking of one container or one thing, one jar, one whatever, is, you have to think of a bunch of small ones, and they're all running in that tiny little all directions. And then you need to kind of, keep an eye on them and make sure that you have proper APIs to talk to each other, that they are talking to each other the way they're supposed to. And those that are talking, they're actually allowed to talk to each other, and those that are not allowed, they're not to do. So there is a little bit of API management and this kind of things that you need to think about. Fortunately, we have things like API management, we have service mesh, we have open API, we have a lot of things that can help us with this kind of things, right? But that's the point. So first one is loose coupling. So try to create applications with as much loose coupling as possible. So, you might not want to create too many of those microservices. So you need to agree with yourself, with your project, with your customers, whoever that might be, probably first of all with yourself is like, how tiny little, how granulated you want those services to be, right? The other thing is putting things in containers. So number 2 is containers, and containers is, you might think of it, it's one of ways of getting away from works on my machine kind of problem, right? Because back in the days when you would deploy something, it would fail and you would just come back with the world's probably, the most known excuse after it's compiling, saying, look, well, I promise it worked on my machine, I don't know what happened, and it's one, of course, that's one way to address that. But then also containers do a few other things, which is probably not the first thing you think about, but it's there as well. It's that it makes your applications predictable. So your builds are actually predictable. If it builds and is fine on one machine, it's mostly will be fine on another machine with a similar architecture. But it also creates, predictable builds, but it also creates predictable deployments, because that if you build the whole thing and that it will build in a similar way in another machine, and maybe you don't even have to build it on another machine because you have already container that you can push into a container registry, that it will be also deployed in a similar way. You don't have those long lists of installation instructions that we used to have, and human error factor being very, very high there because somebody just forgot to copy paste the line, or a script that is optimized for bash and it's been run on totally different kind of shell or versions, or all those possible nightmare scenarios. Here most likely it will be predictable, both builds and deployments. Again, mileage might vary, things might happen, but still. And portability, so you can actually, that's a part of lock-in avoiding thing, right? You can just actually pretty much again take your containers and bring it to something else, and most likely they will run as long as it's the same architecture and everything, right? So there is a comment, as in 2001 Space Odyssey, monoliths are not evil. Exactly. I mean, they're not evil. They're actually, they're okay to what they're used for, and you might still be wanting to use them for some reasons, and you might still want to keep them because they just work for you as well. But you don't really need to run and just dismantle all the monoliths and create tiny little services just because. You probably need a good reason for that anyway. And there is another comment. So of all the places I've worked, none had a small team just to make sure that the base images were always up to date with the security part. Yes, exactly. So that is a problem. So that's a security issue, right? And that's a bit of a downside of containers, because containers are a kind of single-use kind of thing. Like we use masks probably right now. You just use them once, and then when they're done, you throw them away. You don't kind of reuse them or rebuild them, because I've seen people doing that with containers as well, and that was a very big no-no. And I had to kind of try to explain, like, please do not SSH into your containers and fix things. Fix it outside, build it then again, replace it, and because it's just once, build once, don't touch it again kind of thing. Because if you do all that, you lose all this way of automation that we'll be talking in a second, right? But security is a very important thing, because with containers, you need to be able to maintain those and look after patches and stuff, but you also need to be sure that you don't pull weird containers that are not actually official containers from somebody, because you don't know who else put some kind of surprises in it, some kind of script that it's very hard to find that will create a backdoor to something or whatever, So all those kind of things are important. So there is a question from Brad. Containers are serverless. You don't get both if you go fully serverless. Yes, kind of. It depends on what you define as serverless, because you can actually, obviously you can think of functions as serverless, but that's a tiny little pieces of code. But you can also do serverless in containers as a containers, and there are quite a few examples. I mean, Knative in all different shapes and sizes and different managed versions of that is a typical example of where you can go serverless. It will do all the serverless things for you, but it will also be a container-based thing. But yeah, it depends on how you look at serverless. What would you actually say is serverless? Because we'll get to that. We'll get to that in a second. Another thing that I want to talk about first is automation, because automation is a kind of key here, right? It's automate as much as possible. Automate where you build your containers, automate your CI/CD pipelines, automate the way you deploy things, automate all kind of things that you can automate. Do it as soon as possible, because one, it will save your time. You will be doing much more fun things. You'll get to develop rather than actually, deploying things or looking at things being deployed and stuff like that. You can just, do commit, do push, and magically in like a minute or so, everything is deployed. Isn't that beautiful? I mean, I don't know how it's for you, but for me, it's a kind of, it makes my day, just creating a pipeline, knowing that it works. But you will still have to maintain that pipeline, right? You'll still need to create all that. And the other thing is that apart from saving time is that, it will also be less error prone, because like it or not, we're humans. I mean, we're not robots, and robots are really good at doing mundane kind of over and over again tasks. We human, we get bored, we do mistakes, we do things. And I mean, tell me of anyone that have never made a mistake while deploying things and possibly have one or two downtimes on the application called after them or something, right? So computers don't do that. Scripts don't do that. They kind of still do the same thing over and over again. So automation is good for you. And again, you can put things in containers, you can create loose couplings without going to the cloud. Resilience is another thing again, right? We talked quite a bit about resilience already, but again, you create an application that is resilient, that is supporting the whole concept of the whole idea of resilience by being fault tolerant. So like, for example, quite a few frameworks and stuff, they would have even their own, like, for example, MicroProfile that I play quite a bit with. It has annotations where you can do like fault tolerance, you can do retries, you can do strategies for different retries and things like that. And all that is a very, very important thing. You can even do failovers. So if one service fails and you try 2-3 times, you can define how many times. You can say, oh, well, if that fails, just fail over to this service. I know it's a bit worse. It's worse with, I don't know, with respect to quality of data or whatever, but hey, it still works. It doesn't fail. So you can do things like that. So keep in mind, and again, you can do this thing and it will increase your quality of your applications without being without having to go to the cloud. Observability is another thing. So you're actually making your applications available to both applications, or like programmatically, and also humans can actually go and take a tiny little look at the application and see how it's doing. You can record number of calls it's processing, memory, CPU, whatever it might be, whatever you want to actually observe an application, you're actually making that thing observable. And that's an important thing again here. And security, we talked a bit already about, right? So we talked a bit about all that, but think about security from different ways. So one way that already was mentioned, that was really, really good point about the container security and everything. But here it's also authentication, authorization. Zero trust is another thing that can be mentioned when we talk about this thing. If you haven't looked at that yet, please do. It's a really, really interesting concept of, trying, basically trust no one, pretend that everybody is not trusted. Not that when you pass DMSAT, like the way we used to have, we put some things in DMSAT and something behind it. If it's behind, then it's full party. Yeah, if there is a security vulnerability and you actually get past that, then you are part of that party, and you might not want hackers on your party. I don't know. So zero trust might be another thing of thinking, and all that you can do without going to the cloud. So cloud native does not mean that you go, marry with the cloud. Serverless is probably the one that is most connected or mostly kind of thought of when with respect of cloud, right? So because for a lot of people, going serverless means that you need to pick a cloud, you need to pick something, you need to pick a product, but it doesn't have to. The thing is that there is a lot of products and a lot of different ways of doing that on-prem, and it will still. So the tiny icon there I have on the bottom, that I kind of try to address each of those 5 things, is this for serverless is a tiny little icon for money. Thing is that you'll save money. That's kind of the first selling point of serverless, and that is that can be in different ways, right? If your application is on cloud, you will not be renting as much hardware as you might have without serverless, without this. What is serverless? Serverless does not mean there is no servers, because you still need servers, right? That means that there is no management. Or much less management of whatever you're running. And that can be different things. So it can be functions. So it can be very tiny little pieces of code that are very independent, that can do whatever they do and just live happily somewhere. And that can be, again, on the cloud, but that can be also on-prem solutions. There are quite a few of them that are, for example, something called Funky. So it's a Red Hat thing with using Quarkus, and it's still creating this tiny little functions. It can be something else. There are quite a few serverless functions projects out there that you can use and install on-prem. But it can be also container based. It can be things like Knative is a very good example of that, right? Because Knative is basically something that if you install Knative yourself, you'll see that you will end up installing Kubernetes first, and then you do some installation on top of that with Knative, which will in the background install Istio and a bunch of other things. So it is actually a Kubernetes, Istio, and some stuff on top of it, but it hides all that complexity behind Knative project. And then there are managed version of that, right? There is, for example, for Google, there is something called Cloudrun. And Cloudrun is basically a managed version of Knative that they manage for you, but it's still serverless. You can deploy containers to this thing, and it will scale to, I don't know, say 0 if you want to. And actually, by default, it will. And you will not spend money on using those resources that you're not actually needing, right? But this money thing is actually still valid if you're running on-prem as well, because as I told you in the beginning, this comparison with this super monster drag racing cars and huge engines and stuff that are basically, you can almost hear them drowning in the gas because while they're just idling. And this is kind of this thing don't want to do this with your servers as well. I mean, you don't want to have hundreds of servers just standing there and creating heat and blinking. I mean, it's really beautiful to look at them blink, but I mean, it's probably not worth the money spent on the hardware and electricity and cooling and all these things, as long as they're just idling there. And same thing here. You can actually install some kind of serverless solution that will let you share resources between different applications and kind of scale up and down whenever they're needed, because that probably your applications are not all of them are used at the same time or things like that. There's a question from Colombia. Hello from Colombia. Do you recommend any resource to learn about cloud native applications architecture? There are quite a few. I'll try to share some on Twitter. So follow me. I'll show you my Twitter account in a second. And also, Google for Cloud Native, CNCF application, CNCF Foundation, Google things like Knative. There are quite a few books written on that as well. That also, I'm pretty sure they are. I'll try to look up and share that tonight or as soon as I can. Some resources and books. I'm pretty sure there are quite a few that are also made by things like, for example, publishers like O'Reilly, which are freely available for. Sponsored by different vendors, so it can be Red Hat, can be Microsoft, can be something else. So I can share some of those as well. It's a lot of things you can have a look at. So yeah, I will do that. And speaking, oh yeah, you can actually see my handle under my face somewhere here, and you will also see it in a second on this slide, because we're still having 5 minutes left of our talk, and I mean, worst case we can go a little bit over time, but there is another session starting, so probably we shouldn't do that. But you're more than welcome to. You've been really great asking questions and writing comments, and and commenting on the through the whole presentation. That's really awesome. That's exactly what I wanted you to do, so thank you very much. And if you have some other comments, any other questions, anything, we still have some minutes left, so feel free to actually write some stuff and comment and share your thoughts and things maybe I should add to next version of this talk, because this talk is kind of keeps on evolving, and I mentioned different things that I see and experience and get some feedback on. So feel free to add some more stuff. You're more than welcome to ping me on, probably the easiest way is to ping me on Twitter. My DMs are open, so that's my Twitter handle that you see it there. And apart from that, you can just comment both publicly and offline, or like in direct messages or anything. I'll be more than happy to discuss things about all things Java, all things cloud. It's always fun to talk about that.
Hi, Rustam.
Hello.
Josh, I'll just come into the stream really quickly to ask this question. It is kind of a loaded question.
Oh,
so
nice.
You may have, go over the time here, but basically, do you have any recommendations for different containers that should be used in the cloud, or not only to that end, but do you have any recommendations for ways that developers can easily get into using something like Docker to deploy their containers to the cloud and whatnot?
This is a big question. This is really great question, and that could be, and probably should be, another full talk.
Yeah, it could be a full talk.
It is, but it is amazing question. It's really great that you ask, because short version of that. Thank you very much for asking this question. So the short version is okay. I'll do first, Brad, and about the reminder. What does Cloud Native means to you? Docker and Kubernetes, AWS Lambdas. What do you use when you implement the production code? So stack details, Knative was helpful. More. All right. Let's do this first, and then we'll go. It's kind of connected to what Josh asked. So Cloud Native, that's what I said. I mean, Cloud Native to me means quite often things that can be run in the cloud, but doesn't have to be. So it can be serverless, but it doesn't have to be. But it's typically microservices, typically one way or another, where you have to define, because with just Kubernetes you can create scaling and everything. That's fine, but you cannot control that well how they can talk to each other in the network and everything. So that's kind of the Istio part comes on top of it. And if you don't want to deal with all that, you might want to look into the Knative that kind of hides some of that. But the point is, like, for me, it's very often it's those things that kind of satisfy to one way or another those 5 things. But again, that's me, right? It might be a bit different for you. So what I use to implement in production code, again, it differs because I work for different customers and stuff. Now, whenever I do things, I go very often with microprofile, just because It's kind of tiny little and small. If you haven't tried it, try it. It's Eclipse Foundation, open source, really nice tool or framework for that. I use quite a bit, play quite a bit around with Quarkus, and I'm not affiliated with Red Hat or IBM or any one of those at all. So, I mean, I can actually mention that I use it. Because it's fun, and you can also convert it to native images, and you can do a bit faster deployments and faster startup times and stuff like that. When it comes to so I would create a tiny little micro profile project. I would put it onto, I don't know, Open Liberty, Wildfly, Cumulus E, whatever application server that might be, Helidon, or Quarkus or whatever. And then I would just put it on either cloud or just like open local application, local ways of serving those things. And Docker is one way of doing containers, but remember that containers is actually a open technology, so there is different other implementations that are using containers that are not necessarily Docker. So there are a few other, especially with this license change that they had recently, there is another way of you can alias a Docker to another tool, and it will do pretty much the same. So there's a competitive tool, competing tool also created by kind of coincidence by Red Hat. But yes, it's same things and same things. You can basically create alias Docker equals that, and it will just work. So it doesn't have to be, but Docker, yes, it's probably one of the most used ones and one of the most kind of widespread ones. And back to what Josh said. Well, there's a lot of thank yous in chat, so thank you all for joining as well. And I'll try to answer now a little bit, go into what Josh asked. It's a kind of a very big question, but so we had a really great chat. I'll share the link to that one as well. So we had a really good chat with a colleague of mine and Dmitry Churko. He is an OpenJDK contributor and also working quite a lot with that. We actually talked quite a bit about this different types of containers. So tiny containers, regular containers. We have talked about, how like native images and GraalVM and all those kind of things. So I'll share this talk. We just recorded it a few weeks back, just around New Year Eve, and then we just kind of pushed it, made it available, I think 2 days ago for everyone. So I'll share a link to that in my Twitter feed as well. So we talked quite a bit about that. So I'll actually say go listen to that, and there is a lot of pointers there as well. But with Java in containers is a bit. It's been a lot of misunderstandings, and there've been a lot of kind of misconceptions when it came to that, because, well, it's slow, it's too much footprint, and all of that. It's actually, most of it is wrong, and well, pretty much all of it is wrong, I would say. And the thing is that you can actually do all that, and you can actually create containers in different ways that will make those containers very snappy, very fast, and tiny little containers as well. So I will, that was a thanks for Josh. So thank you, Josh, again for asking a really good question. Oh, this is okay. There is a question from Brad. This is what is my preferred cloud? This is a difficult question, because I work for a consultancy company, so I very often work with whatever I'm kind of asked for. The way I would say I have most experience with GCP. So I worked mostly with Google Cloud. On the second place after that, like experience-wise, not preferred or favorite or whatever. That's a different question. But experience-wise is GCP, and I kind of like it too, because it's like the UI and it kind of feels I know where to find it, but it can be just because I use it so much, right? But then I have also worked with Azure. I worked a little bit with AWS. So it depends on the client. It depends on this like public private sector. It depends on different kind of fields those clients are in. It depends on the country even, because we have offices in different countries, and it depends also on that. So I cannot really. I mean, if I would have been working for a kind of public product company, I would probably it will be easier for me to answer it. But here I'm trying to kind of stay. One thing, I'm trying to stay independent and say, try to find out what works for you. And the other thing is that I kind of worked with most of them, and I have some kind of way of experience with one of them. But I work quite a lot with Google. I run Google Developer Group for clouds here in Oslo and all the other things. So I mean, for me, it's very often the thing that I go for. But again, it doesn't have to mean anything really. Yeah. So this is there was some comment from Brad again. That's cool. So yeah, you also have the same kind of experience. That's really nice. Good to hear that. And there are some more thank yous. And well, thank you all. Thank you, Rodrigo. That's a familiar name. Anna as well. There's some names that I've seen before, and some people that I haven't seen for quite some time now, because now all the conferences are being done in front of the screen, unfortunately. But let's hope that we'll get to meet at different conferences. So I'm still signing up for quite a few conferences, and they're starting to appear some offline conferences, so in-person conferences. So I hope they will be there, and I hope I'll be able to be there. I really hope to be able to see some of you or all of you, or there. So I think if there are no more questions, I will say thank you very much, and feel free to ping me and ask more about all this stuff. I'll be happy to talk to you.
Thank you, Rustam. That was a great presentation, great session.
Thank you very much.
We appreciate everyone's attendance, and we're going to close this stream, and you can go and catch the next session. Thank you.
All right. Thank you. Bye-bye.